Delegate call is all about borrowing functions from contract B while using the storage of contract A. There are multiple use cases for when you could use it in your projects, and it's also very dangerous, so you need to be aware of how it works. So let's start with the first example, where we exploit a victim contract. As you can see, we have our victim contract, which uses a library called lib. Let's see how lib works. Here you can see that it has a tone function, which changes the owner to the message sender. So this way, anybody who calls this function could become the owner of this contract. But since the contract lib is the contract B, so the contract which is being called by contract A victim, as you can see here in the delegate call, when you call this function, you won't become the owner of this lib contract, but of this victim contract, because we use the storage from the victim and the function from the library contract. But it's easiest to understand when you see it in practice. So let's look at our attacker contract that we'll use to exploit the victim contract. It's rather simple. We just provide the address of the victim and have only one function, which calls the vulnerable function, and it calls it using encode with signature call function. Of course, if you see functions like this without any requires like only owner, you could call it just like this using a simple interface in Remix, for example. But the problem is you will become the owner of the library contract, not the more important victim contract. And that's only if you have access to this contract. Because by default, even though this thing is integrated into the victim, you won't be able to access it through the interface. So we need to use the low-level function like this. So let's deploy everything and see how it works. I'll deploy the library contract first, then victim contract with the address of library. And now switch my account to an attacker, so somebody else. And now I'll deploy the attack contract that's pointing at the victim. Now just call the attack function, and let's check the owners. So the library contract should have the previous owner, so 0x0, no owners here, because we use the storage from the victim contract. But when we call the owner in the victim contract, you can see that it's the exact address of my attack contract. So now if the victim contract has any functions like withdraw that require only owner modifier, then my attack contract could call it and drain all of the funds. Second use case, this time not an exploit, but making an upgradable smart contract with proxy and multiple implementations. We copied the contracts from other user, but heavily modified them. So let's see how they look like now. As you can see, we have satellite 1 and satellite 2. Those are two implementations that we'll use in our proxy contract, which is called main contract. As you can see, the structure of those contracts is very similar, and it's done on purpose. That's because we'll use functions from those implementation contracts, but the result of the functions won't be saved in those variables, but actually in the variables in the main contract, the proxy. As a user, we don't ever want to call the implementation contract directly because we don't want to change the variables in those implementation contracts. We want to use the proxy, and it's proxy's job to select the current implementation. So let's see how can we call the setVars function while using the implementation and changing the storage in the proxy contract. Down below you can see we have our setVars function, which uses the delegate call, making this contract the contract A, and this contract the contract B. Here you can see that we access the setVars in a low-level way. But it's not the only option. We don't even need something like this. We could always use a fallback, where we use the message data instead of encoding the function signature here. It's rather hard to visualize it without deploying the smart contract, so let's deploy it first. So first the implementation, maybe both of them to save time later. And now let's deploy the proxy with an address of the implementation on. Here we can call the setVars function, passing number like for example 5, and some value because it's a payable function. And now we can see that the number is set to 5, but in the implementation, the number stayed at 0. If you don't really know how fallback and receive work, make sure to check our previous video. But to call the fallback, we need to call the callData function here, but we need some message data. So to create message data, I'll use a helper function like ABI encode. And this way, I'll create a function signature. So let's see this contract. Let's deploy it. And now pass the function name and then the argument, so let's say 10. Now we can copy our encoded signature in bytes and use it in call data. So right here, also passing some value and executing the function. Let's see whether the num has changed, and it's changed to 10, so that's how it's supposed to work. And of course the implementation stays at 0. So we can use this fallback to call any function because we provide the message data through this low-level call data transact option. And both ways, even if we update the implementation to the second one, so I'll copy the address of the second one and use the set implementation function, which changes the address of the current implementation here. I can do the same low-level interaction again and check the number, and it's supposed to be 20 because in the second implementation, as you can see here, the number is multiplied by 2, so that it's easier for us to see whether the implementation has changed to the second one. Use case number 3. In this case, we want to support delegate call in our smart contract, but also we want to have a modifier like no delegate call and use it in some of our functions, so this way you can't really call the greet function using the delegate call. We got the contracts from the original article, link in the description with some explanation if you want to check this, and adjusted it to one of the newer Solidity compiler versions. As you can see, this case is rather simple, but could be useful, and it's been used even in Uniswap v3, and it leverages the immutable original address. Immutable means that you won't be able to change it anymore. You can only set the variable here in the inline mode or in the constructor. So this way you can be sure that the calls are not really delegated and that the results of the functions, like setting variables, will apply for the variables from this smart contract, not variables from another one. So let's get back to our contracts and deploy both of them. We have our greet function, which we can call directly, but that's not really the point. It's all about those two functions and calling the greet one from the sender. So we just copy the address of the receiver and paste it here. First, we are using call greeting function, which calls the function in a normal way here. As you can see, using the call, not the delegate call, so it makes a big difference. And it passes, but when you call the delegated greeting, you can see that it will be rejected, and that's because of the modifier right here, no delegate call. So if at any time you want users to prevent calling your functions using the delegate, make sure to use this modifier in your project. If you like this video, make sure to like and subscribe, because that's a signal for us that you like this type of videos and you want us to record more. And we also really appreciate it, so thanks and see you next time.